Yeah, thanks to everyone for coming and to Nathan for a great talk that I think really managed to introduce 30 years worth of literature on this topic in 30 minutes, which is really amazing. My work on this subject really picks up where Nathan left off, and it's I'm going to try to talk a little bit about things I've done, and what I do builds very tightly off of some work by Amy Finkelstein and Laurent Einov. And so I'll sort of start with that and then move into what I've been doing. And this is based on two joint papers that I have, one with Neil Mahoney, who's my colleague at Chicago, and one with Andre Vega, who's at Oxford, and who some folks at MSR might have met when he visited the lab, and he'll be visiting again next month if any of you want to talk to him. Okay, so after the theoretical literature that Nathan highlighted, there was a move to try to look at whether this stuff actually happens in practice. And in particular, there was a large body of literature trying to test for whether adverse selection actually exists. So people tried to look, if we look at more generous insurance contracts, if we look at people who are insured versus people who are not insured, is it actually the case that people who are insured are actually riskier than the people who are not insured? And that literature led to a few conclusions. So one conclusion was that there is not very consistently compelling evidence that there is, in fact, selection. Some cases found evidence of selection, but there were a lot of cases where you didn't find evidence of selection. So there wasn't nearly as clear of a message as people might have thought. Second, at least one explanation for this that seemed to have a fair bit of empirical support was that it wasn't that there wasn't selection at all, but that there were multiple different dimensions which were going in opposite ways. So like one way to think about this is imagine that, some people are more hypochondriac than other people, but and some people are more sick than other people. Well, the hypochondriac people are going to also want a lot of insurance, but they're probably going to take better care of their health. So they're going to be, better risks to take on. And so that might sort of cancel out. And overall, now that wasn't exactly what was happening in the data, but that's like a sort of simple way to think about it. And another thing that people found was that very strong evidence of imperfect competition in these markets. Brand effects, small number of firms, potentially colluding with each other, et cetera, et cetera, et cetera. These would introduce the sort of frictions that, sorry, I don't know your name. Josh? Reshef. Yes, that Reshef was highlighting, and that would potentially, okay, so these are not modeled in the canonical environment, and another thing that's not modeled in the canonical environment that there's also very strong evidence of is what's called risk adjustment policies, where the government will come in and subsidize people who are really costly to potentially get rid of some of these adverse selection problems. Okay, so all these things are not in the canonical Rothschild-Stiglitz environment, and you might think that they actually have a really big effect on the types of conclusions that you would reach in that environment. In particular, imperfect competition will undermine this ability to do these like really extreme cream skimming things where you just offer a slightly different contract and suddenly you attract lots of different people. Multidimensional heterogeneity might offset the benefit that you get if you start offering a less generous plan. Well, maybe you get some healthier people, but also maybe you get some people who don't worry about their health, and you don't want those people. And so forth. Okay, so on the other hand, as Nathan was mentioning, if you take a standard Rothschild-Stiglitz model with all these menus and so forth, and just throw in multidimensional heterogeneity and imperfect competition and these other things, the model is like a total mess. And it's really hard even reaching the conclusion that there doesn't exist an equal. I mean, it's hard to analyze the model at all. And so sort of in the aftermath of all these papers, there was a move to try to say, well, imagine that we just revert back to the super simple Akerlof environment, where there's just a single contract. Can we at least say something there in the presence of multidimensional heterogeneity or some of these richer things? And that literature is what I call like the price theoretic approach to this. So the idea is rather than taking like a really simple environment, but then allowing firms to do all these complicated things with menus and so forth, let's restrict what the firms can do to something really simple and maybe, at least in some markets, not so unrealistic because we actually don't see that diverse contracts being offered, but allow for a really rich environment in terms of what's going on in the real world. And maybe this is familiar to some folks from AGT, where you sort of think about simple mechanisms in rich environments. Okay, so let me describe the most canonical paper that did this. So there's an empirical paper by Einov, Finkelstein, and Cullen, and a theory paper by just Einov and Finkelstein that describe the following environment. So there's a single contract. You can either buy this contract or not buy this contract. People have a multidimensional type, theta, which determines how much value they get from taking this contract, v of theta, and the cost to the insurer of offering the contract to them. And there's some smooth distribution over the multidimensional type space. At a price P, the people who are going to buy the contract are going to be those who have a value greater than P. And let's call that set capital theta of P. Then the quantity for any given price is going to be the integral of the density over that set. So the quantity is measured as the fraction of the population that chooses to take up this contract. The inverse demand is then just the inverse of this, right? Again, this is very familiar from standard auction type stuff. And then the total cost of serving the people who buy the contract is going to be the integral of the cost of people who choose to take up the contract when the price is a certain level. But of course, given that we've got the inverse demand, we can just say the cost is a function of quantity, where we feed it through the inverse demand and then figure out the set of people who will buy at that price, and that gives us a cost function. Then we can define the average cost, which is the cost divided by the number of people, and the marginal cost, which is the derivative of the cost function. Perfectly competitive equilibrium is then defined as average cost being equal to price, whereas the social optimum constrained to the fact that we don't know people's, we're not allowed to offer different contracts to different types of people, so we don't have any more information than the firm does, and we have this single contract that we can offer, is where the marginal cost is equal to price. Because that's the case where the next group of people who you'd bring in if you lowered the price are worth it to society to bring in. And that gives you a really nice little graphical depiction of what goes on in this market. So the average cost curve under adverse selection is downward sloping. That is, the first people into the market are the costliest people. The next people are less costly, and so forth. And of course, if the average cost curve is downward sloping, well, the marginal cost curve is going to lie below it and slope downward more quickly. And so the social optimum occurs where the demand intersects marginal cost, whereas the equilibrium is where the price equals average cost. And so there's a distortion in this market, which is just the standard deadweight loss triangle between the equilibrium here and the social optimum here. And that's shaded here. Okay, and this is super easy to implement empirically if you have variation in the prices, because that will map out the demand curve. But you can also look at, okay, what's the average cost of people when the demand is at different levels as the price varies. And that's what Laurent, Amy, and Mark Cullen did. And so here's the empirical analog of this picture. They got these quantities for different prices, and they got these average costs for different quantities induced by different prices, and they draw out the average cost curve. they fit a linear fit to it, and then they can, based on that, draw out the marginal cost curve. Here's the demand curve that they drew to it. Here's the intersection, and here's the distortion. Yes?
Do you think about this in the previous, in the Akerlof Stiglitz framework, in the sense that the marginal cost, sorry, the average cost is their E of P?
Yes. Yes, so that will be a special case. That's a special case of one dimension in a particular structure to the types. This is a generalization of that, but it only allows for a single contract. So it generalizes the type space, but it specializes the contract space. Okay, so let me just show you in this framework how we can account for the Akerlof unraveling. So imagine that you had a demand curve that was sort of sandwiched in between the average cost and the marginal cost curve here, which basically corresponds to Nathan's example where there's these types going all the way up to 1. Then what you could get is that, well, if I tried to charge this price, then my average cost would be here. Well, would be here. If I tried to charge this price, I would get this many people. That would lead my average cost to be here. So to break even, I have to charge here and here, and we go all the way up until we have nobody in the market. Now, one interesting remark, these are linear curves which like intersect here. Another way that you can get this that doesn't require some of the conditions that Nathan was talking about is imagine that some people were willing to pay arbitrarily much, but they were also arbitrarily costly. And that actually corresponds quite well to like empirical observations that like there are some people who like just millions and millions of dollars of cost. Then you can go all the way up, and it can be sandwiched in between without like being sandwiched in this really silly way. It can be sandwiched in between just because they're all going to infinity, and you can still get unraveling. Yeah, Nathan?
Like the way that would nest into Rush LC was Rush LC was just a binary event, so the type space was clear. It was just a probability, right?
Yeah.
Here you have principal.
Very bad events, exactly.
Have, a contract over every possible level of the outcome that you see, and so it's that would
exactly.
be one particular way to nest that.
Yeah, exactly.
That's
right. Okay, so but there's another scenario that we can think of actually that gives an opposite sort of prediction, which is advantageous selection. So imagine that like we just had people differing in their hypochondria, right? Then the people who most want to be in the market are going to be the lowest cost people. And the people who come into the market later are going to be higher cost. And that leads to this upward distortion in the number of people who get served. Because then the average cost curve is upward sloping, and the marginal cost curve is above it, and there are too many people in the market. And there's a fair bit of evidence that this happens in finance, and I'll talk about that in a second. Okay, so now this is where my work with Neil comes in. So we say, okay, well, we like cost curves and demand curves. Imagine we now want to put imperfect competition, like Reshef was saying, in. Well, that's actually like super easy now, right? Because we can just say, let's draw out the marginal revenue curve and set marginal revenue equal to marginal cost. And then, and this is slightly less trivial, but pretty close to as trivial, you can put an imperfect competition. And you can say, well, the monopolist internalizes marginal cost and marginal revenue. Competition internalizes demand and average cost. You can easily show that various models of imperfect competition will give you a weighted average of each of these two curves, and you can have a parameter theta that maps in between them. Okay, so, yeah?
Just say what you mean precisely when you say put in imperfect competition.
Okay, so there are two different ways we do it. One is with a Cournot model. Do you guys know the Cournot model? Yeah, so like firms offer quantities, and they take as given the quantity offered by all the other firms, and they're symmetric. And another one is differentiated Bertrand competition, where you have some like friction, like people have some inherent preference for one insurer over the other, and you do it in a sort of symmetric way, and then there's.
Okay, so we're in the setting of multiple firms still.
Yeah.
And when you say imperfect competition, you mean imperfect competition amongst the firms.
Yes.
Okay.
So, it's just somewhere between monopoly and perfect competition, basically. So what do you get in that context?
The previous slides, by the way, were just monopoly was the same as perfect competition, or is it?
No, the previous slides were comparing perfect competition to the social planner. There's no monopoly in the previous slides. There's no market power. Just like Nathan never talked about market power except in the one question, it was all perfect competition or the social planner. So now we're introducing what a monopolist would do. And what a monopolist would do is just set marginal revenue equal to marginal cost, as we're used to. And so then we can compare the monopolist outcome to the perfectly competitive outcome. So in the case of adverse selection, monopoly is always worse than perfect competition is. Because intuitively, the monopolist wants to earn positive profits, at least weekly. So he can't ever do anything like charging price below average cost. But in the context of advantageous selection, that's not so obvious because the market oversupplies, monopoly undersupplies for the reasons we're used to, and the optimum is in between. In particular, there will be some optimal level of market power, theta star. Theta is how we parameterize market power, such that you get the optimal quantity, and there could be too little or too much market power. So we actually looked at this quasi-empirically. We used some data from the used auto loans, the market for loans to purchase used autos in the subprime segment. And we found that under plausible values of the market power parameter, that you would have gotten basically a huge subsidy as a result of excessive competition, too little market power in this market. Yeah?
Is there actually a microeconomic way to explain the market power parameter? I think this is also kind of
This is what I was saying.
Jason's question.
So under Cournot, it's
is there a story of what the consumer's doing?
Under Cournot, the more firms that there are, the less market power. Under differentiated products competition, it's the more similar consumers perceive the firms to be.
So I don't need to think about a world with multiple time periods where people are stuck
No.
with the firm they currently have. I just need to think about...
You can microfound it in that sort of a way, but there are the goal of this whole project, as you may be starting to get, is to like get rid of a lot of these microfoundations and to say there's lots of different ones that all map to the same
This way.
curves.
Okay.
And you can microfound it that way. You can microfound it using collusion. You can microfound it using Cournot, but I mean, there's a lot of different microfoundations. Okay. Another interesting thing that that Neil and I found was that once you introduce, okay, so I mentioned this thing of risk adjustment. What is risk adjustment? That means you pay the firms if they take unhealthy people. So one way of thinking about that is that you change the cost curve. So rather than it being this downward sloping thing, it becomes flat where everyone has the same cost as the average person in the population. That's like a standard risk adjustment scheme. And under perfect competition, that's really a good thing to do. Why is that? Well, if we move from this downward sloping thing to something that's flat, you're going to increase the quantity towards the optimum. But that's not at all obvious with monopoly. Why is that? Well, intuitively, the monopolist is scared that if he raises his price, he's going to get like unhealthy people. So like imagine the marginal person for the monopolist is like a young invincible. A lot of people are in the market, but he really wants to get those healthy people in. That's holding down the price he wants to charge. He's scared that if he exerts his market power, he's going to lose that guy. But now if you give him risk adjustment, you give him a big subsidy, and he might want to raise his price because now he's not as worried about the adverse selection. So you actually subsidize the monopolist, and you accomplish the opposite of what you wanted to accomplish. And that's shown graphically here. The problem is that the marginal, even though the average cost curve is always above the average for the whole population, the marginal cost curve crosses the average for the whole population at some point. And then if you risk adjust, you bring it all up to here, and he actually charges a higher price when you intersect that with the marginal revenue curve. Okay, and we calibrated this to some...
How does risk adjustment occur with the monopolies? Does the government tax? How do they get the monopoly?
Well, so the way I think about this is it's usually in the employer-provided market. So employers usually have some baseline self-insured plan that's not very generous. And then there's an alternative plan that they offer that's more generous but is offered by an insurance company in an imperfectly competitive way. And they can either offer subsidies for you adopting that are risk adjusted, or subsidies that are just flat. Yeah. Okay. And in fact, so we calibrated this to data from the employer-provided insurance market, and we found that not always, but in a fair fraction of plausible cases, it's actually socially harmful to do this risk adjustment. And in most cases, it's harmful to the firm and the workers together. And it's like a way basically to give more profits to the companies that are offering the insurance. Okay, so then, a major flaw of this model is that there's just one contract, right? There's no contract design. And as Nathan pointed out, a lot of the action in these markets comes precisely from the product design. So what we tried to do in this paper with Andre was to say, let's try to keep with the nice tractability of this framework, but just take like one little more step towards allowing richness. And we tried to do that, from the perspective of sort of industrial organization folks, just using like a hoteling model, where you just have some characteristic of the product that you can adjust, right? And so we just added in some continuous product characteristic X that firms could choose in addition to their price. So we started with a monopoly model to keep things simple. And consumers will now have a value which depends on the continuous parameter X. You can think of this as the generosity of the plan in the context of insurance, and on their type. But their cost also depends on X and their type. And I'm going to define a set of people who are marginal to purchasing the product or not. So there's one contract being offered, but the firm can design it by using X. And the set of marginal people are those who have a value that's exactly equal to the price. Now, if the firm is going to set a price optimally, more or less, as I said before, with marginal revenue and marginal cost. The interesting part is how does the firm optimally set its design feature. And that's according to this equation here. So it's going to set the average marginal value that people get from a little bit more of the characteristic for the people who are on the margin, not for the average people, but for the people who are on the margin, equal to the average cost of providing the additional characteristic to the average person who buys the product, plus this covariance term. So this is the covariance along the set of people who are marginal between the marginal utility people get from a little bit more insurance and the cost of serving these people. You can think of this as being like the cream skimming term, right? If you give a little bit more insurance, that's going to particularly attract some types of people. Those people might be more or less costly on average than other people, and this term reflects that. And this term is divided by the firm's marginal surplus. So marginal surplus is, in the auction theory language, the divergence between the virtual and the standard value. So it's that, F over, 1 minus F over F term. Okay, so this term is very intuitive, right? This is just saying how much is it going to directly cost you to provide this more insurance to the people that you already have. But the two interesting terms are this one and this one. Now this one is actually very classical. It originates in a paper by Mike Spence. He only studies it in the one-dimensional context, but it's very closely related. The point is that this is basically price discrimination. So the idea is you don't care about giving more utility to inframarginal people. You only care about giving more utility to marginal people because they're the only ones you can charge to. So anything you can do to sort of screw the inframarginal people and benefit the marginal people will help you. But the sort of more novel thing to our paper is this covariance term here. And this is, as I mentioned, the cream skimming incentive. But in the context of monopoly, this term shows up exactly the same in the social planner's condition. So this is, the social planner would want to do exactly this too, because the social planner doesn't want to sort in more costly people either, because they may not be worth covering. So the only divergence between what the monopolist does and what the social planner does is this term here. He would do it based on the average person, whereas the monopolist does it based on the marginal people. Yeah?
Can you explain the margin, like expectation on the margin again?
Yeah,
What
so-
is the space
so-
of data?
So imagine that there's a two-dimensional type space. So this is like hypochondria, and this is like health. And the people who are very hypochondriac or
Glen, you probably want to use this word.
So imagine we have hypochondriacs and sick people. So the people who are going to buy the contract are going to be above this, right? And the people who are not going to buy the contract are going to be below. And the people who are on the margin are these people here. So you take an expectation over that. And it's a zero measure set, so there's a little bit of like technical details, but basically there's a natural notion of taking the expectation over that. Okay. So then, you know, the interesting issues arise as you go into, I mean, there's interesting issues here too about like how a firm would want to design its contract. But to really connect to what Nathan was talking about, we then want to introduce some competition into this model. But presumably, at least potentially, imperfect competition. And the key thing there is that as competition comes in, this marginal surplus, this like markup term that the firm has is going to go to zero, because it's not going to be able to get any of those rents because the people are going to be moving to the other firms. And that's going to cause this term to blow up and these terms not to matter. So this term is going to have to be equal to zero, effectively, the covariance. And that's going to be like this cream skimming effect. The firm is not going to be able to allow any way that it can use this characteristic to on average attract more people. And so you get a nice equilibrium condition, which is that this covariance has to be equal to zero. Okay, so then we, yes?
Sorry, I'm still not understanding. So you were saying, where is the richness of the contract, additional richness of the contract coming from? Because you can consider that as for given X, you're just going to charge the same price, right? So can we just consider this as sort of like, I'm going to have, for each X that I observe, I'm going to have the single price contract. I'm just going to have a lot of contracts.
You only have one contract.
So under this setting, you can consider this as like, for given X, you only have one contract.
That's right.
Right?
You guys don't take X.
But you get to pick X. The firm is picking X. That's the focus.
Maybe he may be wondering what happens if the firm offers a menu of different
Well,
actions?
I'm just not discussing that now. I mean, we can talk about that later, but that's not in the scope of what I'm talking about. I'm talking about a model where the firm chooses this contract term. So we explore the implications of this in the context of a, okay, so then we put some competition into this. So rather than just having one firm, we have two firms on a hoteling line. So there's some differentiation between them. So they're competing with each other, but they're not perfect substitutes for each other. And then they also choose this product characteristic. And they're symmetrically differentiated at these two ends of the hoteling line. So there will be symmetric equilibrium. And then we get this implication that the covariance is going to have to be equal to zero in selecting between the two firms. And if if the distribution of people's health or other things that cause them to choose insurance is independent of how much they like one insurer over the other, that's going to require that the covariance of this marginal utility and cost in the whole population is going to have to be equal to zero. We then consider a specific model of this where people have constant absolute risk aversion preferences over the contracts that they get, and people differ along three dimensions: their risk aversion, their variance, and their mean risk. Risk aversion you can think of as being a little bit like this hypochondria thing I was talking about. The value to insurance of people is then going to be A times sigma squared, and that's like the fundamental gains from trade associated with it. And then we let x be a linear actuarial rate of insurance. So that is the fraction of your costs linearly that I cover. And then we get an equilibrium that's characterized in terms of the regression coefficient of this insurance value on the mean. So that's a sense of like how closely are these correlated with each other. If that's positive, that says that people who are sicker, on average, also value insurance more. So that's going to be really bad. On the other hand, if that's negative, these things might offset each other and you might get some insurance. And what we show is that if beta is less than -1, you can get a positive insurance equilibrium existing. But in fact, we went and calibrated this to some existing data, and you get a beta about 12. So you get a lot of adverse selection. Now, it turns out that we can, if there's enough adverse selection, get the market to actually collapse like Nathan was talking about. Turns out that in our calibration, beta needs to be about 24. So beta is in this nether region where no equilibrium ends up existing. So we get back to the Rothschild and Stiglitz conclusion if there's perfect competition. However, with some market power, that doesn't happen. So if you start making the firms differentiated and you give them enough market power so that they get a markup of about 60% or so, then equilibrium starts existing again because you can't do so much cream skimming. And here's a graph of what happens. So this shows as a function of the percent markup over cost that the firms end up having, which is a measure of their market power, what the equilibrium outcomes are. So X star is the symmetric equilibrium amount of insurance that's offered. Q star is the symmetric equilibrium fraction of the population that gets insurance. And then this shows the fraction of the best welfare that we could achieve and the best consumer surplus that we could achieve that is realized. And the interesting thing is that the amount of insurance offered rises rapidly as you have more market power because there's not as much cream skimming. But on the other hand, prices go up, as we talked about in the other model, and so the fraction of the population covered goes down. And so welfare has a single peak at an intermediate amount of market power. And interestingly, you can achieve 98.5% of the first best welfare with this intermediate amount of market power, though you achieve the maximized consumer surplus at about the same point, though it's at a lower level of consumer surplus than of market power. Okay, thanks.
Sorry.
Yeah.
Can you say again what market power is?
Market power is how different, in this model, it's how different people perceive the firms to be. Some people prefer one firm over another. Some people prefer the other one. That inhibits them from being perfectly competitive. It creates the frictions that Reshef was talking about. Another thing that could do that was search. And so, I mean, there's many different ways that you can generate this market power, but that's a natural way to do it.
Policy that the government would follow if it wanted to like grant market power.
Well, one thing is antitrust forbearance, which in fact this industry has had at various periods, and it's gone in and out of having. Another one is not making the products too transparent. Another one is they have succeeded in that. So I mean, there's a ton of evidence that there's a lot of market power in this industry. And in fact, this optimal load factor is really quite close to the load factors that actually exist on insurance products. So whatever it's doing, it might not be doing it too badly. But the other, I mean, another thing that it can do is barriers to entry. It can, and there are a lot of barriers to entry in this industry. It's a huge amount of regulation you have to satisfy. What you want to avoid is having a lot of fly-by-night companies that come in and say, oh, we're just going to cream skim off the best guys by offering some crappy contract. You want everyone to have a big stake in the market, so they want to steer people towards profitable contracts rather than just coming in and cream skimming off in a small way. So
People get their insurance at least held through the employer.
yeah, so an employer is the regulator in that context. So we had an op-ed in the Bloomberg View that sort of goes through this in the context of the Obamacare exchanges and tries to map it to that and suggests, what are some policy things that, would grant market power. Yeah, David.
Is there an empirical exercise you can now do with your imperfect market power model and
Yeah.
try to back out what the adverse selection parameters look like? If I understood you correctly, in
Yeah.
your last slide, you said that the empirics looked kind of highly adverse selection, which I thought was odd because at the start of your talk you said that there'd been empirical work that showed that that it was kind of mixed. And
Okay.
I took the previous slide
Yeah,
as you
yeah,
kind of say
yeah.
it's an artifact of the
Yeah.
model you were trying to
Okay,
fit.
so the calibration that we used was to this Handel, and Winston paper, which came after that earlier generation of empirical work, and find strong evidence of adverse selection. And yes, so an important conjecture in the previous literature is one reason that you don't see so much adverse selection was that the firms have enough market power to steer people enough so that you might not end up having that much market power in equilibrium. I mean, adverse selection in equilibrium. And to the extent that that's true, yes, you could potentially use this sort of model to do it. I'm not sure that this is necessarily exactly the right model because it doesn't have multiple contracts. And Eduardo is going to talk about a perfectly competitive market model with multiple contracts. And we're thinking a little bit together about whether you can come up with an imperfectly competitive model with multiple contracts that combines what I've been doing in this work with what he's been doing in the paper he's about to present.
So what happens if you add individual mandate at some low bound?
Well, that would put a lower bound on X star. Whether that would create equilibrium existence or not depends on whether effectively at that level the second order conditions are satisfied. And I think that the minimum insurance that you need to get that to happen here in our calibration is about 50%. So if you, but Obamacare is above that. So I think we would probably predict that with a mandate there would be an equilibrium even under perfect competition that lives at that lower bound. Which I don't think is a terrible description of what's been going on in the market, but yeah. Not obviously a bad thing from a social perspective, though, to be at that lower
Is
bound.
there a sense that, this individual mandate with the exchange kind of introduce more competition, but, at the lower bound? So maybe we are shifting from market with more market power to more competition with the...
Yeah, okay, so let me talk about that. That's sort of what we covered in this article. So here's what we said in the article, and then here's what I actually think is true. So what we said...
Article meaning op-ed or...
Op-ed, yeah. So what we said in the op-ed, and we sort of made a nod to what I think is actually true, but what we said in the op-ed is, look, Obamacare did put in this lower bound, but like if everyone races to the bottom, then we've unraveled the market for like really good insurance, and maybe it's bad. And in fact, like this model would suggest that we want like almost full insurance for everybody because it's assumed away any moral hazard, and it's assumed away lots of stuff. Even if you put in realistic levels of moral hazard, the standard estimates that come out of here will still say the optimal insurance is like 90%, and Obamacare exchanges would unravel it down to 60%. And that would be really bad, and so we might want to say, well, you should either mandate people into much higher levels of insurance or have imperfect competition so you can raise back up the levels of insurance. However, so that's what we said in the article. However, I actually think that that's because these estimates are all messed up. So I think the reason that these estimates are all messed up is that like the risk aversion that these estimates rely on is about 2 to 3 orders of magnitude bigger than what anyone would consider reasonable risk aversion numbers. And the reason that they're getting it is that if you think about it, when you go into like choose your health plan, which is what all this is based on the choices that people make, everyone like chooses to get like really, really low deductible and like really low coinsurance, but they're like scared and they're not used to like paying money for their health care, right? So they like don't like that idea. But that's irrational. Like they're like literally throwing away money. They're basically like paying more in the premium to like, basically get back less even in like the worst possible state of the world from the insurance company. And that's just stupid.
We should explain Josh's paper.
And the model, what?
We should explain Josh's paper.
Josh Schwartzstein's paper?
Well, just because there might be psychological reasons why they do want to get a lot of insurance. It's not so clear that it's
Okay, well, anyway, I mean, so yeah, so some people would argue that this is completely irrational, and I think from an individual perspective, it is pretty irrational. But other people would argue that, like, well, I'm afraid that in the future I might like not want to go and get something I should done for me if I have to pay for it, and so I might like get more insurance just to encourage myself to like get health care that I know that I'm going to be tempted in the future not to get. That's one story. Or another story you could have is that, you know, it genuinely is irrational, and people like, you know, so there are like different layers of irrationality you can pile on top of it. But I think without piling a lot of layers of irrationality on top of it, you can't really make sense of the numbers. They don't add up. And so this idea that we should have like 90% insurance is based on numbers that are like completely implausible in terms of people's risk aversion. And at that level, like of course you want to have full insurance, but if people are like unbelievably risk averse, and like there's only a reasonable amount of moral hazard, we know from like the stuff we did on taxes, you'd want to have like 100% taxation. But like, you know, we also know from that stuff that like if you have reasonable amount of moral hazard and reasonable amount of, you know, you don't want like 100% taxes, you want like 50 or 60%. And that's like roughly what is at the bottom of the Obamacare exchanges. So my like gut reaction to it is actually like 60% is a pretty good place to land, even though that's not exactly what the article said. Because if you take people's revealed preferences, well then you do want market power. But if you say people are irrational, well maybe you don't want market power because you actually want to get down to like zero, you know, lower insurance levels. So, yeah, Jason.
So for one of the things that you showed here is that even with like a fixed price and a fixed quality,
Yeah.
you're going to be serving a large fraction of the market.
Yeah.
And if you want to, that's, I assume, you got that from a study of data, like that you used, because
You mean this thing here, you mean?
the observation that you said that you want to serve most of the market, like 90% of the market,
Yeah.
right? That observation has some assumption on the environment that you're in.
Yes. Okay, so
I'm wondering
you mean that it would be socially optimal to serve the whole environment, or that it would happen in equilibrium?
that it would happen in equilibrium.
So which paper, you mean this thing here?
I mean, it seems like any of them would have to have assumptions to.
Yeah, I mean, so Nathan has a paper showing that there's lots of markets where there's pretty good reasons to think that in equilibrium we don't have anyone getting served. There's other studies that have other markets where a lot of people are getting served. So it depends on the particular market that you're talking about.
So, you know, if you took, for instance, if you took what Nathan was talking
Yeah.
about and you relax the IR constraint, like we were
Yeah.
talking about, right? So you would actually be able to then serve a large fraction of the market.
Yes.
But now it seems like there have to be some assumptions on this setting you're talking about, so that if you're going at it, I mean, so for instance, if you're looking at it with a single price like you're talking about,
Yeah.
using your price theoretic approach,
Yeah.
versus, you know, a menu that every single
Yeah.
probability is getting, like,
When is there a large fraction of the market served, you're asking? Like what are the conditions?
if you bound the IR constraint that you're allowed to violate, right? You could ask, what are the conditions you need to be able to serve?
Yeah, I mean, that sort of stuff is like really easy to do with these types of pictures because, you know, you would draw out a demand curve, you would draw out a cost curve, you would draw out a you know, and you would say like, when is it the case that there's an intersection of this curve over this curve from above to below? And, you know, there's some characterization of that, and, you know, like there's some basic results out there, but it's not something that's been like studied a huge amount in the sorts of settings that I'm most interested in with multidimensional heterogeneity and so forth. Nathan quoted some nice results that he has about it in the one-dimensional heterogeneity context with the single probability of a loss occurring.
I actually didn't understand your question. So if you relax the IR constraint, like isn't trivially then everybody served?
So
Well, but he said you might relax it to different extents.
the point is, I guess, so.
You might have some subsidy, for example.
The difference between the two things that you guys were talking about is that here we allow one contract, and in your setting we allow many contracts.
Yeah.
And you could ask, you know, what is the difference, what is the handicap that I'm putting on this you know, these poor insurance companies to only allow one contract. And, you know, if I'm allowed to relax IR, for instance, then that handicap should come up in sort of the degree by which we have to relax IR until we can maybe serve everybody or something. And so if we're gonna study this kind of a phenomena, right, obviously the you know, distributional assumptions on the risk are gonna be important in studying that. And I'm wondering if there are canonical assumptions that people use for these markets, so that if you wanted to study, you know, a rich subset where you could show that, you know, you didn't have to relax IR by so much or stuff like this, that you could then work in this subclass, like, you know.
I mean, some natural things, like, Jason, is like the more gains from trade there are, like, in other words, the more, like, risk-averse people are, or the more variance that people have relative to their mean, the easier it is going to be to sustain a lot of insurance without a lot of subsidies or intervention. What?
Variances, so there's an ordering in terms of mean residual risk, like you get in a lot of them. You have variance already in a single dimension, in a single contract space, there's a variance.
Okay, so what I was saying is, if you have CARA preferences, and then the bigger the variance is relative to the mean, the easier it is to sustain insurance, because the variance is just as a benefit to everyone, because the insurer is risk neutral and the insured is risk averse. I mean, if there's some correlation between the variance and the mean, then that's no longer the case. So if there's which is true. So like we found the reason why we ended up finding that beta was positive was not because risk aversion was positively correlated with mean risk. Actually, that was negatively correlated and would have given you a negative beta. But the problem was that the variance is super positively correlated with the mean. And so in that case, you actually get like more adverse selection as a result of that. So, but the more gains from trade there are, the easier it is to sustain. The more negative correlation there is between these two dimensions, the easier it is going to be to sustain. Yeah, I mean, you could easily come up with some other comparative statics, but those are like classic ones. Yeah.
So I have a question on a different topic, but
Yeah.
I was wondering if you could talk a bit about monopolists.
Yeah.
Because so in Nathan's talk, you're saying there are two options: either the market unravels, or there's no equilibrium.
Yeah.
But that actually leaves out the case where there's monopolists, right? In that case, there is.
Well, his model.
Money if and only if there's no Akerlof unraveling.
Right. Yeah.
If and only if there's.
And
there's
so,
no
and then it seems like.
Yeah, and with monopoly in our model, and in fact, there's a classic paper by Stiglitz, 1977, showing this, that with strict monopoly, you can get, I mean, the monopolist can profit when there's profits to be made.
Yeah.
Because he
it's
doesn't
not a
face
zero
cream
profit.
skimming.
Right.
Yeah. He doesn't face cream skimming.
But is this good? Is that solution good for people compared to like, is the market power,
Well, so
much better than a monopolist situation?
yeah, so I can show you that. Okay, so my last slide. Okay, so you see over here is the monopoly solution. I didn't even picture it, but it's basically as this goes towards infinity. And what you see is that the welfare is highest here, and then falls significantly, though definitely not to zero, as we go towards the monopolist solution. So these are concave right now, but eventually they get convex if you keep going out, and it levels off towards the monopoly solution.
And do you expect that to be like quite low? I guess it's hard to say.
Well, I mean, it depends on the particular distributions. Here you achieve about 70% of welfare, but only about 50% of the maximum potential consumer surplus, whereas you get about 80% of consumer surplus and 98.5% of welfare with an intermediate degree of market power. Because you're trading off the harms of monopoly, which is that they're trying to extract surplus and they're excluding people from the market in the process, but you get the benefits of more insurance. So it's a trade-off.
I'm sorry, when you say welfare here, do you mean utility of consumers?
I mean aggregate welfare, including the monopolist profits and the utility of the consumers.
Okay, so it sounded like it was close to zero, but if they're maximizing their revenues, it wouldn't be zero.
No, I don't think it's close to zero. This is 70% of the best possible.
Yeah, but you said it was way down here.
No, I don't think so. I think it'll level off maybe at a 50% or something like that. I mean, I don't know exactly what it is. I'd have to check it out. I don't think it's going to get that much
Q,
beyond
what
this.
is Q? X is generosity and Q is 1 in this case.
It's the fraction of people covered.
Fraction. Yeah.
And so maybe the monopolist is extracting like almost all the welfare, or?
Well, I don't think he's extracting almost all the welfare. I think he's leaving a significant amount to consumers. But, yeah.
So compared to this.
Yeah.
this
I mean, as you see, the gap between these two things is monotonically increasing as you go over to here, because that's because the monopolist is extracting more and more profits, because he has more and more market power.
All right,
Okay, great.
thanks.